So let's continue. Then what you do is, there's a damage. Maybe we can say the skin here is damaged. So when you have corrosion behind here, then normally the whole skin will be affected. So what you do, you cut off damaged area, remove it. When you do the cut, standard practice, you reserve for another row here. Room where you can put a doubler, you put another row. So for the cut, when you cut, you try to prevent this stringer from damage. So you just cut off the skin. You just remove the affected skin. So when you remove the skin, what you do, you will put double repair later on. So you will see again, we have how slide over. So what you do, we have skin. This is the first skin. Here. So we have skin, okay, and then the skin coming out and behind. So what you do when you cut off, you remove the whole thing of skin. And if you can see from the side, so remove the whole thing, but you keep the stringer because we do not want to disturb the stringer, and obviously we hope if we got corrosion behind here, the stringer will not be damaged. So leave it like that. So first, what you need to do, you need to design the repair. As we have been discussing earlier on the approval of the repair, here is concept. Why? Where do you get the concept? This is concept you will learn from your structure repair design. You learn from your structure repair manual. When you got defect, remove the defect, cut out the area, and install doubler. Before you install doubler, you must ensure first is doubler material. Second, doubler thickness. Then you must also rivets type, rivets diameter, also rivets length. So this is the information that you require to do the detailed design of the doubler. So before you do detailed design, the doubler material, the doubler thickness, you need load, rivet type. You need to know the number of rivets. So to design this, to get the detailed design of this, you need load. Very important that you need load. So you have to have the load. So the load, how to get the load? You must look at how the structure is behaving and how the structure is working. If this is a section, normally this splice is come from the fuselage cross section. So we have one skin coming here another seam coming here, and we got 3 fasteners. So here basically is a curve, and what load you get, you have pressure here to the surface of the skin due to the fuselage pressurized, because fuselage is pressurized. So, and because the pressure, the load, the skin does not take the true thickness load, so the load will come into a shear. So the load will transform into this action. Okay, this action. So then we have also this tend to shear. Then we also have this fuselage is basically a section of a cylinder. So this cylinder will have experience bending, experience shear, and also it can be twist, experience torsion. So from that understanding, what will be the load here is due to this pressure skin, we have tension load here. Due to bending and torsion of fuselage, we have tension load here. Okay, and also for the cut, since the skin does not carry true thickness load, we also have shear load, shear load, shear load, shear load around the cut. So this is how the load, how this cut will be loaded, and from the load we design the, we choose the material, we choose the thickness. For the doubler, we choose, we decide how many rivets that we use to do the repair.